I'm sure you're familiar with the concept of simplifying the following half plus 1/3. You'd probably find the common denominator, which is 6, and then you say 2 into 6, and that gives you 3. You multiply that by 1, and then you do the same for 1 over 3. 3 into 6, 2, multiply that by 1, you get 2. And this would simplify to 5 over 6. But what if we were given 5 over 6 and we wanted to work backwards and find 1 over 2 plus 1 over 3? This is what we call decomposing into partial fractions. And in this video, I'm going to show you exactly how to do that. So subscribe and let's dive right in. So we've got two main scenarios when you talk of partial fractions. We've got a proper fraction, and then we have an improper fraction. And under both proper fraction and improper fraction, we then have three possible scenarios where we're dividing with either a linear factor, a quadratic factor, or a repeated factor. So this is probably all gibberish to you. I'll explain what all this means in a bit. I just wanted you to understand the number of scenarios that we're going to be dealing with. So we either have a proper fraction or an improper fraction, and regardless of which scenario that is, it usually splits into either of a linear factor, quadratic factor, or a repeated factor. So if you have a fraction in the form a over ax plus b, you can tell that the denominator ax plus b is in the form of a linear function, y equals ax plus b. So in this case, we say that we have a linear vector. So now we're going to walk through an example of where we're decomposing into partial fractions when we have a linear vector. Okay, so let's look at this question. It says let f of x equals 2 plus 11x minus 10x squared over 1 plus 2x times 1 minus 2x times 2 plus x. Express f of x in partial fractions. So I want you to look at the denominators here. We have our first denominator here, 1 plus 2x. That's a linear function since it's in the form ax plus b. Then we have our second factor, 1 minus 2x. That is also in the form ax plus b. So that's another linear factor. And then we have our third factor, which is also linear. So what we would do here is first, let's just rewrite our function f of x, 2 plus 11x minus 10x squared, and that is over 1 plus 2x, 1 minus 2x, 2 plus x, and we'll say equal to, so for a linear factor, we write in the form a over ax plus b. So you take this factor, the first one, 1 plus 2x, and then your numerator, you put any capital letter that you want. So that's a, and then we're going to do the same. Since it's linear, we're going to do the same. That's b over 1 minus 2x. And then for the third one, that's 2 plus x. So you c over 2 plus x. Now what we're going to do is we need to get rid of the denominators. So what we're going to do is we're going to multiply by the denominator that's on the left hand side. So this equation becomes 2 plus 11x minus 10x squared. So that denominator on the left hand side cancels out. And then if you multiply a by the denominator, it becomes a times 1 minus 2x times 2 plus x, and then b becomes 1 plus 2x times 2 plus x, and then finally c becomes 1 plus 2x times 1 minus 2x. So now we need to evaluate a, b, and c. And how we're going to do this is we're going to pick a value of x that will make one of the brackets equal to 0. For example, let's look at this bracket, 2 plus x. What value can we substitute x with that will make this bracket 0? We can substitute x with negative 2, and that will make x 0. and effectively it will cancel this whole term out. 2 plus x is also present here, so it will also cancel this whole term, and you only remain with this term that contains c. And so if we want to evaluate c, we can substitute x with -2. So let x equals -2. So substitute x with -2, so that becomes 2 plus 11 times -2 minus 10 times -2 squared is equal to, we're not going to write the terms in a and b because they will be cancelled out. Then we have c times 1 plus 2 times -2 times 1 minus 2 times -2. And now let's use our calculator to simplify the left-hand side. So that is 2 plus 11 times -2 minus 10 times -2 squared, and that gives us -60 is equal to, and let's evaluate the brackets for c, 1 plus 2 times -2 times 1 minus 2 times -2, and that gives us -15c. Divide both sides by -15, and you get c is equal to 4. And now we have to look for another value that will allow us to evaluate either a or b. Here we have the bracket 1 minus 2x, right? That's present here and here. For this bracket to be 0, we have to substitute x with +1 over 2. So we can say that let x equal 1 over 2, and then we'll substitute here. That becomes 2 plus 11 times 1 over 2 minus 10x squared is equal to, we know that it will get rid of the bracket with a and the brackets with c, so we only remain with b. So b, that's 1 plus 2 times 1 over 2 times 2 plus half. Now this should be, I should have substituted x there, so that it should be times half squared. And let's substitute the left hand side into our calculator. 2 plus 11 times half minus 10 times half squared. That gives us 5 on the left hand side. And then if we simplify the coefficient for b, that's 1 plus 2 times half times 2 plus half, and that gives us 5 as well. Divide both sides by 5, b is equal to 1. Okay, so now we want to evaluate a. So for that to happen, we need to find the value of x that will get rid of this bracket 1 plus 2x. That's the only bracket that doesn't affect a, and that bracket affects both b and c. So for 1 plus 2x to be equal to 0, x must be equal to -1 over 2. So we're going to say let x equal -1 over 2. So this becomes 2 plus 11 times -1 over 2 minus 10 times -1 over 2 squared, and this is equal to a 1 minus 2 times -1 over 2 times 2 minus 1 over 2. So let's punch the left hand side into the calculator. That is 2 plus 11 times -1 over 2 minus 10 times -1 over 2 squared, and that gives us -6. And then let's evaluate the coefficient of a. So that's 1 minus 2 times -1 over 2 times 2 minus 1 over 2, and that gives us 3a, and divide both sides by 3. So -6 over 3, that gives us a is equal to -2. So we can conclude that therefore f of x is equal to, let's go back to the statement we made at the very beginning. So we've got a over 1 plus 2x, and we've evaluated a to be -2. So this is now negative 2 over 1 plus 2x, and we will do the same. B is 1 over 1 minus 2x, 1 over 1 minus 2x, 1 minus 2x, plus C is 4 over 2 plus x. 4 over 2 plus x. So these would be the partial fractions. And what this means is that this fraction that we have over here can be decomposed into 3 partial fractions, which are the partial fractions that we have written down below. And that would be our final answer. Okay, so now let's look at an example that contains a quadratic vector. So we know that a quadratic is anything that can be written in the form ax squared plus bx plus c. So if we look at question number 3 here, we have 2 plus x, that is a linear vector. So we'll follow the same steps that we followed in part 1 when we want to evaluate it. And then we've got 3 plus x squared. Now the highest power there is 2, so that is a quadratic, and it can be written in the form ax squared plus bx plus c. So when you have a quadratic vector and you're decomposing into partial fractions, it would then become ax plus b over your quadratic. So for a linear vector, it's bx plus c. For a linear vector, we say it is just one letter on top. So for example, if your linear vector is ax plus b, it would be c over ax plus b. But notice how the numerator then changes for the quadratic vector to become ax plus b. So let's delete this and let's go through the question. So let's write out our f of x, 14 minus 3x plus 2x squared, and this is over 2 plus x times 3 plus x squared, and this is equal to, let's start with our linear vector 2 plus x, so it's just any letter over the linear vector 2 plus x, and then we have a quadratic, so that's bx plus c, bx plus c over our quadratic 3 plus x squared. And again, we need to get rid of all the denominators, so we'll multiply through by the denominator on the left hand side. So this becomes 14 minus 3x plus 2x squared is equal to a times 3 plus x squared plus bx plus c times 2 plus x. Okay, and now we'll follow the same steps as in the first example. So let's look for a bracket that we can eliminate. So 2 plus x looks like an easy one. So to make that bracket 0, we can substitute x with negative 2, and it will eliminate this whole term over here, allowing us to evaluate a. So let x equal negative 2. 14 minus 3 times negative 2 plus 2 times negative 2 squared is equal to a 3 plus negative 2 squared. Let's evaluate the left hand side. That's 14 minus 3 times negative 2 plus 2 times negative 2 squared. So that gives us 28. On the right hand side, we have 3 plus 2 squared, which gives us 7. So that's 7a. Divide both sides by 7, you get a is equal to 4. And now if we go back to our equation over here, you notice that no value of x here will cause this bracket to equal 0. As we're going to substitute x with 0, as you can see, our b is multiplying x, so that's going to eliminate this b. And then we already know what the value of a is, so we'll substitute a with its value over here. So that will allow us to evaluate c. So it would become 14. This is let x equal 0. 14 minus 3 times 0 plus 2 times 0 squared is equal to a, which is 4, times 3 plus 0 squared plus bx, which would be b times 0. So that then becomes c times 2 plus 0. So if we simplify, well, 14 is equal to 4 times 3, that's 12, plus 2c. And so this becomes 2c is equal to 14 minus 12, which is 2. Divide both sides by 2, you get c is equal to 1. And now we have to evaluate b. So now that we have both the values of a and c, we can simply substitute in those values, and then we substitute x with any number that we want that is not 0, because we've noticed that 0 will get rid of b, and so that will allow us to evaluate b. In this case, we're going to use x is equal to 1. So let x equal 1. So that becomes 14 minus 3 times 1 plus 2 times 1 squared is equal to a, which is 4, times 3 plus 1 squared plus bx. Bx is 1 plus c, which is 1, times 2 plus x, which is 1. So if we simplify the left-hand side, that's 14 minus 3, 11, plus 2, that is 13. And then on the right-hand side, we've got 4 times 3 plus 1 squared. It's 4 by 4, 16. And then we've got plus b plus 1 times 2 plus 1, which is 3. So that's 13 is equal to 16 plus 3b plus 3. So 13 is equal to 19 plus 3b. 3b is equal to 13 minus 19, which is negative 6. Divide both sides by 3, you get b is equal to negative 2. Now we have all the values of a, b, and c, and we're going to come back to this expression and simply substitute. So a is 4. We can say that f of x is equal to 4 over, what's our linear vector, 2 plus x, 2 plus x. And then we've got our second term, which is a quadratic, which has a quadratic vector, bx plus c over 3 plus x squared. B is negative 2, and so that's negative 2x plus c, which is 1 over, what's our quadratic, 3 plus x squared. And this would be our final answer. We have decomposed f of x into its partial fractions. Now let's look at the third scenario where we're dealing with a repeated root. Okay, so when we talk of a repeated root, that's when you're only seeing something like, for example, x squared. You could also consider this as a quadratic, but usually when you just see it as the function and then the squared is outside, we consider this a repeated root. For example, here you have 2 plus 3x, and then outside you've got that power 2. It almost looks like a completed square form. That's when we talk of a repeated vector. In other words, for example, x squared, you could write it as x times x. So what we have here, 2 plus 3x squared, would be 2 plus 3x, 2 plus 3x. So this is what we call a repeated vector when you've got that power 2 over there. And how we decompose when we have a repeated vector, it looks something like this. I'll use the example x squared. So if our repeated vector is x squared, you'd end up with a over x plus b over x squared. This is how you decompose when you have a repeated vector. So now let's go through the example that we have over here. So we've got f of x is equal to 8 plus 5x plus 12x squared over, that's 1 minus x, which is a linear vector, times 2 plus 3x squared. Okay, so we need to start by, in fact, let's get rid of that, the f of x over here. We need to write our statement. We're going to say that this is equal to, we have our linear vector 1 minus x, so we can put our a over there, and then plus, since we have a repeated vector, this becomes b over 2 plus 3x, then plus c over the squared version, 2 plus 3x squared. And again, we need to get rid of the denominators, so we're going to multiply through by this denominator here, and that becomes 8 plus 5x plus 12x squared is equal to, that's 8 times 2 plus 3x squared plus b times 1 minus x times 2 plus 3x plus c times 1 minus x. And now we have to evaluate a, b, and c. So we'll start with this bracket. Looks like the easiest one. So if we substitute x with 1 there, you end up with a 0. And this bracket is also present here. So that means we're evaluating a. Let x equal 1. So that's 8 plus 5 times 1 plus 12 times 1 squared is equal to a times 2 plus 3 times 1 squared. And let's simplify our left hand side. That's 8 plus 5 plus 12. That gives us 25. And then on the right hand side, we've got 2 plus 3. That's 5. 5 squared is 25. So that's 25a. Divide both sides by 25. You get a is equal to 1. Okay, and then we've got the bracket 2 plus 3x. So to make that bracket equal to 0, we can let x equal to negative 2/3. So, and that will eliminate a and b. So that allows us to evaluate c. So we're going to say let x equal negative 2/3. So that's 8 plus 5 times negative 2/3 plus 12 times negative 2/3 squared is equal to, that c 1 minus minus 2/3, so 1 plus 2/3. So let's simplify our left hand side. 8 plus 5 times negative 2/3 plus 12 times negative 2/3 squared, and that gives us 10 is equal to 1 plus 2/3, that's 5/3c. So multiply both sides by 3/5. So 10 times 3/5, and we get c is equal to 6. You can see that there's no way of us evaluating b by making either of the brackets equal to 0, because b contains both of the brackets, 1 minus 3x and 2 plus 3x. So we'll say let x equal 0. So that becomes let x equal 0. That's 8 plus 5 times 0 plus 12 times 0 squared is equal to a. So we already evaluated a, and a is a 1. So that's 1 times 2 plus 3 times 0 squared plus b times 1 minus 0 times 2 plus 3 times 0 plus c, which we evaluated to be 6, times 1 minus 0. Okay, so if we simplify our left hand side, we get 8, and this is equal to our right hand side. We've got 1 times 2 squared. 2 squared is 4, so that's 4. b times 1 minus 0 times 2 plus 3 times 0, so that gives us 2b. And then finally we have plus 6, so that's 8 is equal to 10 plus 2b. 2b is equal to 8 minus 10, which is negative 2. b is equal to negative 1. And now we have all the values of a, b, and c, so we can conclude that therefore f of x is equal to we've got 1 over 1 minus x, 1 over 1 minus x, then b minus 1 over, that is 2 plus 3x, and then finally c, which is plus 6 over 2 plus 3x squared. And this would be the final answer. This is how this fraction over here decomposes into its partial fractions. So now let's learn how to decompose into partial fractions when we have an improper fraction. So first of all, how do we even tell that it's an improper fraction? We're going to compare the highest power in the numerator to the highest power in the denominator. If the highest power in the numerator is equal to the highest power in the denominator, that is an improper fraction. Or if the highest power in the numerator is greater than the highest power in the denominator, that is also an improper fraction. So for example here, if you were to expand our denominator here, you'd notice that you'd get a quadratic, and we know that the highest power for a quadratic would be the power 2. And the power 2 is also the highest power in the numerator. As a result, this means that what we have is an improper fraction. So when decomposing into partial fractions, you usually want to start by evaluating a constant before you proceed to decompose, just like you would a normal proper fraction. And to do that, there are two methods that I generally use. The first one being of polynomial division, and then the method that I prefer, I don't know the technical name for it, but I'll explain what it is. It's basically just rewriting the numerator in terms of the denominator. So in the first step, we're going to rewrite this 4x squared minus 13x plus 13. The first step is to expand your denominator. So if we expand our denominator, that becomes 2x squared minus 6x minus x, that's minus 7x, minus 1 times minus 3 gives us positive 3. Then what we're going to do here, we're just going to take our denominator as it is, and we're going to write it on the numerator. So that's 2x squared minus 7x plus 3. And this is all over 2x squared minus 7x plus 3. And now we're going to try to make this numerator equal to the numerator that we have here on the left hand side, but in this form over here, in the form of the denominator. So we're going to start by trying to get this 4 in the term in x squared. So to get 4, we have 2 over here. It means we have to multiply outside by a 2. Right? That gives us 4x squared. If you were to expand 2 times 2x squared, would give you 4x squared. And then now we have to try to get this negative 13, which is the coefficient of x. So here we have 2 times negative 7x, which would give us negative 14x. But we want negative 13x. So it would be negative 14x plus x, that would give us our 13x. So it means we have to add an x outside the bracket here. And then finally, we've got this 13. On this side, we have 2 times 3, which is 6. So what do we need to add to get to 13? We need to add 7, right? So just to reiterate, we started by bringing this denominator to our numerator. Then we focused on getting the coefficient of x squared by multiplying outside the bracket. So here we had 2x squared, so we had to multiply by 2 to get the 4 that we have here. And then finally we started adding outside the bracket to get the correct terms in x and the term independent of x. So now what we're going to do is we're going to distribute the denominator. So this becomes minus 7x plus 3 over the denominator, 2x squared minus 7x plus 3 plus x plus 7 over 2x squared minus 7x plus 3. And now you notice that we can get the constant that we were looking for. If we cancel out, we end up with a 2 plus x plus 7 over 2x squared minus 7x plus 3. So now we have our constant, and now the fraction that remains is a proper fraction, and we can deal with it as normal. It's proper because the highest power in the denominator 2 is bigger than the highest power in the numerator, which is 1. And so how are we going to decompose that part? That becomes x plus 7 over the factors that we initially had before we expanded to x minus 1 times x minus 3, and this is equal to a over 2x minus 1 plus b over x minus 3. And again, we'll multiply it through by the denominator on the left hand side to get rid of all the denominators. So that's times x minus 3 plus b times 2x minus 1. And to evaluate b, we need to make this bracket 0, and we can do that by saying let x equal 3. So that becomes 3 plus 7 is equal to a times, or a will cancel out since that bracket becomes 0. So that's b times 2 times 3 minus 1. And 3 plus 7 is 10. 2 times 3 is 6 minus 1, that's 5b. Divide both sides by 2, you get b is equal to 2. And then to evaluate a, we need to make this bracket 0, and we can substitute x with half to do that. So let x equal 1 over 2, so that becomes half, plus 7 is equal to a times half minus 3. Half plus 7 will give us 15 over 2, and this is equal to half minus 3, which will give us minus 5 over 2a. And so now we can multiply both sides by negative 2 over 5 to evaluate a. So negative 2 over 5 times 15 over 2, that gives us negative 3. So a is equal to negative 3. So that means for the fraction that we decompose here, the proper fraction, that would then be a, which is negative 3 over 2x minus 1, plus b, which is 2 over x minus 3. Then now remember that we were decomposing the original function, which is a proper fraction, and we started first by getting this constant. So we also have to remember to edit. And so our final answer would actually be f of x's. First we write our constant, which is 2, and then we add the decomposition of the proper fraction. That becomes minus 3 over 2x minus 1 plus 2 over x minus 3. And by doing that, you have decomposed the improper fraction into its partial fraction. Those are all the scenarios for partial fractions. On the face of it, I know it looks like a challenging topic, but with enough practice, you realize that it's actually quite easy. So that's all for today's video. If you enjoyed it, please like and subscribe for more videos like this. Thank you for watching. Bye bye.